So let me tell you a little bit about Bruce Barker. We are privileged to have him. He's been building and inspecting homes for over 34 years. He's an ICC certified residential combination inspector, a licensed contractor, and a licensed home inspector in multiple states. And he is the author of or editor of books including Everybody's Building Code, the NHIE Home Inspection Manual, a practical guide to evaluating decks, and a series of books in the Black & Decker book series, including codes for homeowners, decks, codes and standards, complete guides to wiring, advanced wiring, the guide to plumbing, and the guide to decks. He has a degree in accounting, an MBA in information systems. He is an ASHI certified inspector, and probably most impressively, he is the current 2021 president of the American Society of Home Inspectors. So we want to welcome Bruce to our program, and turning it over. Take it away, Bruce.
Thank you very much, Alex and Hollis. Okay, then we're ready to rock. Let's do Excellent. It. Thank you, everybody, for coming. Let's talk about decks. Now, decks are serious business. As we'll find, they are probably one of the riskiest things we inspect, but that doesn't mean we can't have a little fun with them. So I like to start out these deck classes with what I call Darwinian decks. Okay, what could possibly go wrong in a situation like this? Yeah, it's probably not the world's brightest thing to do to have your support post right in front of a garage door. But I want you to take a look right up here at the plywood underneath. What is that telling you? So there's our Darwinian deck. That plywood tells you there's water infiltration in there, and that can't be good. So what could possibly go wrong? That could possibly go wrong. Now, the good news is that there wasn't anybody on this deck when it collapsed. The bad news is there were people under it, and they were seriously injured. I want you to take a look right up here at the band board. You can tell it's in pretty bad shape. We'll see a close-up of this a little bit later on. Decks are serious business. Now this one, a couple of these come from our Really collection. Yeah. And unfortunately, that wasn't the only deck on this house that comes out of the Really collection. Struts are usually not the world's best idea for deck supports. Fascia is probably even a worse idea for fascia supports. That's another one on the same house. Yeah, this one I did step out on. This one ain't no way I'm stepping out on that one. And then finally, from our some people really should not be contributing to the gene pool, we have this marvel of engineering. Gotta love this job. So they tell me in the instructional design that I'm supposed to tell you what we're going to talk about, then talk about it, and then tell you what I talked about. So for good instructional design, here we go. We're going to talk a little bit about how risky decks are for home inspectors. We'll talk a little bit about the fundamentals of decks. We'll get into flashing, because that's that's a biggie. That's what happened to the deck that we saw first. Deck ledgers, if there's going to be a spectacular failure, that's a very likely place it'll occur. Stairs are inherently dangerous, and deck stairs even more so. And I hope we've got enough time to get at least somewhat into deck guards and handrails. So what we want to do with decks is avoid situations like this. And no, this is not an optical illusion or a tilt of the camera. This is actually the way that deck looked. If you look right over here, you might get an idea of why the deck is like this. Yes, that is indeed a support on a nailed stringer. Gotta love this job. So let's talk a little bit about risks. And of course, anything having to do with risk, we've got to talk about the obligatory scary statistics. Now, frankly, I don't know about the accuracy of these statistics. I know where they came from. The source is a little bit iffy, shall we say, but let's give them the benefit of the doubt and cut them by 75%. If you do that, that's still a whole bunch of injuries involving decks over 5 years, way more than there should be or needs to be. Now, this one comes from Dr. Don Bender out at Washington State. He's one of the gurus on decks. So that source I trust. And this is probably a very true statement. Decks cause more injury and loss of life than any other part of the home structure. So when you're doing a home inspection and you're trying to mitigate risk, ask yourself, where do you want to spend your time? Do you want to spend it on little stuff, or do you want to spend it on the stuff where there's injury and loss of life? Because that is where the big dollars are. That is the business ending and career ending mistake that you can make. Now, in a live class, I'd ask you about how much time do you spend inspecting a deck, and usually I get at most 10 minutes. Which certainly, given the gazillion other things we have to look at in a home inspection, not unreasonable. But just think about it. Do you want to spend maybe a little more time on decks and a little less time on some of the cosmetic stuff? Think about it for whatever it's worth. 20 million decks were not code compliant when they were built. If that's quite believable. Now here's kind of the problem you get into. Even if they were code compliant when they were built, the problem is the code really was not very good until really the past maybe 3 or so code cycles. You go back to around 2009, and about the only mention of decks were a couple of paragraphs in Chapter 5, the interior flooring section. That was it. The code just didn't really address decks. So if you take the fact that 15 to 25 years, depending on your environment, that's a fairly typical service life estimated for a deck. So the bottom line for scary, if you can't find a few really nice juicy defects on a deck, either you don't know what to look for, which at least in part you should have a better idea after today, or you're not spending enough time. Because most decks have some fairly significant defects. So let's talk about the deck demons, the things that can really get you. We're going to count it down from probably the least to the most important. Flooring, yeah, that can be a problem. Is it a big one? Not really. So you probably don't want to spend a whole lot of time on that unless it's just obviously badly deteriorated. Posts and footings, don't blow them off by any means, but you look at pictures of deck collapses, the posts and footings are usually holding up pretty well. The framing, the beams, joist hangers, hardware, that sort of thing, definitely can be a contributing factor, but you probably want to really focus your efforts elsewhere. Deterioration and decay and rust, yeah, that's starting to get something particularly with your fasteners, because not only can the fasteners be pretty severely compromised, but the wood around the fasteners can be compromised, and that can even be worse. So when you're seeing a lot of red rust on fasteners, you probably want to be thinking about if the fastener's in that bad a shape, what's the wood around that fastener looking like? Now we're starting to get into the big money stuff. Guards and handrails, guards can collapse. I have very, very, very rarely do I see a handrail done right. Like we said, all stairways are dangerous. Deck stairways out in the rain, the snow, they're even more dangerous. Ledger attachment to the building, that's the spectacular failures. And finally, flashing. And you might think, well, why is that number one? Well, we saw that earlier. Doesn't matter how many bolts or screws you put into rotted wood, it's not going to hold. So you probably want to be concentrating your efforts on maybe certainly these four, and a good look at 5. And if you're seeing deterioration and decay, you're going to want to be reporting that. So let's talk a little bit first about deck fundamentals, the things we really need to understand. What I like to tell people, particularly when I'm doing pre-licensing training, some inspectors know what to look at. That's easy. What to look at, your standard of practice tells you that. What to look for, that's your defects. Big thing about defects is, if you don't know what a defect looks like, it's really hard to find one. Now, the really good inspectors, they know why they're looking. And that's what we're going to try to get a little bit into right now, is the fundamentals. So the first fundamental is, it doesn't matter what the name of it is. Decks aren't just the thing that hangs off the back of the house. A deck could be on a second story or above. It could be a porch. It could be a landing with stairs. It could be a patio. There could be any number of names on it. So what I want you to do when you're thinking about decks is kind of think about that old saying about the duck. If it walks like a duck and quacks like a duck, it's probably a duck. Well, if it looks like a deck, acts like a deck, built like a deck, then it doesn't matter where it is on the house, and it doesn't matter what you call it. If it's a deck, it's a deck, and you apply the deck rules to it. So kind of want you to expand your mind a little bit about what a deck might really be. So, here we go. You might call this a balcony. Well, and I wouldn't necessarily disagree with you. But is it a deck? Well, yeah, it's built like a deck. Looks like a deck. Got all the features of a deck. It's a deck. Now you might call that a stairway. Well, yeah, it's a deck stairway. That's a landing, a cantilevered landing, which adds some additional complexity, but that's a deck too. Inspect both of these like a deck. So what do you think of? If you think, well, what forces are acting on a deck? Well, that's the one probably most of us think about. And, that's a biggie. If a deck is going to go down, it's going to be pulled down by good old gravity. But that is by no means the only force acting on a deck, and we need to understand that. So gravity, that's going to cause a shear load on our fasteners. So think about your fasteners, think about what they do, and think about how they might break. The occupants are going to put a load on a deck. They're going to put live loads on the deck. They're going to put lateral loads on the deck. What's a lateral? Another word, horizontal. The people moving around, particularly if they happen to be dancing or moving in unison, people can actually put lateral loads, horizontal, on the deck. They can put uplift loads on a deck, a cantilevered deck with the joists hanging off the end of the beam. Everybody gets out there at the end of the deck, for a selfie. They're putting an uplift load on that deck, and we need to be cognizant of that. Snow. You guys live up in, you do get snow up there a little bit more than we do down here in beautiful Raleigh, North Carolina. Probably not enough to make a huge difference unless you happen to be up in the mountains. But snow can put a load on it. Wind can put a load on a deck. It can put an uplift load on it, particularly in high winds. It can definitely put a lateral load on it. You get earthquakes there, not very often, but those can definitely put an uplift and a lateral load, a big lateral load on a deck. Those of you who live in potential flood areas or near the coast, water can definitely put a load on a deck, both uplift and lateral. Decay and corrosion, those forces definitely act on deck. The deck materials, the deck hardware, the fasteners, the joist hangers, the connectors, all of that. Those are all forces that we need to be cognizant of when we're looking at a deck. So there's an illustration. We've got a deck. Particularly if we have part of that of those joists cantilevered, we have the potential then for a kind of teeter-totter effect where we have an uplift load. In most cases, though, it's going to be our good old friend gravity that wants to pull the deck down. But also we've got the horizontal, the lateral load. And many times what happens is that deck will, for whatever reason, start to move laterally, put a lateral load on the fasteners, pull it away from the house, then gravity takes over and does its thing. Now when a deck is designed, it needs to be designed to deal with all of these loads. And that's one of the important things that you need to keep in mind when we're talking about decks. So guidelines. When you're writing a report, it really helps to have something to fall back on to justify your findings. It just should not be your opinion, because opinions, everybody has an opinion. So what you want to do is have something to go back on. Codes are one possibility, and just to avoid misunderstanding, I'm not saying we're doing code inspections. These are just places you can go to for independent confirmation of what you're reporting. Now, the problem you get into with using local codes, and that's a big problem down here in North Carolina, because we have a state code that was completely rewritten. And I need to be careful about how snarky I get about it. But there are places where the local codes are not great, and they're not terribly well enforced. Now, there are places in Virginia, particularly Fairfax County, that have great codes and great enforcement. But the problem is it's a variable. Depends on where you are. The new IRC that just came out, it's good. It has really upgraded the model code for decks. It's still a little weak in a couple of areas, but not bad. Really not bad. And getting better. If you've never heard of DCA 6 from the American Wood Council, you've heard about it now. You can get it at awc.org. It's a free download. Make sure you get the 2015 version. That's the most current. And that's the one I use, and that's the one I recommend. It is really the go-to document for how a deck should be built.
Bruce,
Another guide.
Bruce, did you say the 2018 version?
2015.
2015. Okay.
Yeah. They're supposed to be updating it, but right now 2015 is the most recent. Now here's a little tidbit. It is actually a code violation not to install something per manufacturer's instructions. And here's some code references in the 2021 for that. Just good to know. So things like your joist hangers, your fasteners, oftentimes they will have manufacturer's recommendations. And again, we don't, particularly in home inspections, we're not required to confirm installation per manufacturer's instructions. This is just another good place to go to justify your findings and to add additional gravitas to them. Now, limitations, on the guidelines that we've been talking about. One limitation, these guidelines apply to single level decks. They do not apply to decks with a roof on them like this, and they do not apply to multiple level decks like this. You see something like this, basically you can kind of look at each level, but as a general rule, with something like this, particularly with this part over here, I would just disclaim and run like the wind. Get an engineer. Something that is usually not a problem, but can be, these guidelines assume that the deck is wider than it is long. Like I say, usually not a huge problem, but every once in a while, you'll get a really long and really narrow deck. All the assumptions are that we've got width greater than length. So if you get one of the oddballs, you need to disclaim and get an engineer involved, at least for the structural elements. The deck guidelines don't apply to screen porches that are built basically on top of decks. So the rest of the deck itself, you can probably pretty safely inspect. You just need to disclaim that roof load, because that roof does put both a vertical, potentially an uplift, and definitely a lateral or horizontal load that is not accounted for in the deck guidelines. Concentrated loads, and it doesn't need to be necessarily something as heavy as a hot tub. A good sized kiddie pool can be enough. So any type of concentrated loads, the 40-pound live load that most decks are built to assume that live load is evenly distributed. If it isn't, for whatever reason, an engineer needs to get involved. The deck guidelines are only for residential decks. And residential means one family, two family townhouse, those structures that would be built under the International Residential Code. If it's in any type of high occupancy residential, high rise type units or commercial, these deck guidelines don't apply. Now, balconies. I just want to touch briefly on balconies because we see them every once in a while, and they have the potential to be to fail spectacularly. So the question might become, do the guidelines apply to balconies? Well, if the balcony is built like a deck and you can see the structural components, and that's a key if, then yeah, like I said, it's a deck. You can go back to the duck example. If it's built like a deck and you can see the structural components, yeah, we're good. We're good. Now, what about cantilevered balconies? That's where it gets a little bit more problematic. If you can see the structural components, if they're not covered on the inside, then yeah, there are ways to do it. It's more complicated, but it is possible. The problem you get into is oftentimes what you can't see is what the condition of the deck is at the support inside the house. And if you do have a cantilevered balcony, even if you can see everything but that area inside the house, you need to disclaim that piece of it because you can't see it. And that's where there is a possibility of deterioration that's concealed and could cause a spectacular failure. If the balcony is cantilevered and the structural components are covered, in other words, like that deck that we saw at the first, with the tall posts and the garage door with the plywood underneath, then you disclaim that entire structure and you run like the wind. Because that's the type of, you just can't see it. And that's the type of thing you want to make sure you're not on the hook for. And you want to make sure that your client understands that there are potential risks there, and they might want to have some additional evaluation done at least before they have a big party on So let me just pause here for a second. Any questions or comments before we move on?
I do, Bruce. The hot tub specifically. Can you hear me, Bruce?
Yes.
I can hear you. Go for it.
Okay. Yeah. I see some design area specifically built for the hot tub, and seeing the support systems below that. Some of them are good, some of them are questionable. How would you go about commenting on something like that?
Well, good question. First, are you an engineer?
Oh, heck no.
Okay, then that answers your question. You disclaim. That's the comment. You put a limitation statement in there that says, I don't have any prescriptive way of evaluating this. Get an engineer.
So Bruce, we've got two hands up. Why don't we have Scott Harvey go next?
Well, the only thing is that I am certified to inspect decks per training. So it's on my, credentials. So I kind of feel a little bit inadequate quoting engineer help every time I see something like that. And I'm just trying to fish around for better language.
Well, you may have the NADRA certification. You may even have the ASHI certification.
Yeah.
And I have to be, I want to be really careful about this. Neither the NADRA nor the ASHI nor any other certification certifies you to make engineering statements. And
Understood.
when you start talking about point loads, you're talking about something that requires an engineer. So don't feel inadequate, because you're not. Unless you've got PE by your name, you're just doing your job, and you're being honest with your clients. Next.
Scott Harvey.
Hey, good morning, Bruce. Can you hear me?
Yes, Scott. Good morning.
One of the things that I've encountered over the last several years that I've been in the business is when it's pretty obvious that a deck was built behind the home, and then the homeowner said, well, we'll just make this into a porch, and they put a roof load and so forth. And I didn't know if you wanted to talk to that point at all.
Well, beyond the fact that DCA 6, the IRC, the prescriptive deck guidelines that we have do not cover the roof loads. So basically, you can pretty much go ahead and inspect the rest of the deck, but just disclaim the roof load.
That's okay. That's what I thought you'd say. Okay.
Yeah. Good question. Thank you.
Okay, Remy, go
Next.
ahead.
You're going to have to unmute yourself, Remy. You're next.
Get in on the herd bulls cows, and then
Remy, you with us? I tell you what, is that Richard Stockton?
Yes, sir.
All right, once you go next, Remy, we'll put you on hold here. Richard,
Yeah, I found the mute button.
Oh,
yeah. Stockton, you're up.
Oh, okay. This is in response to the earlier gentleman who's not an engineer, but did take, and got his certification through NACHI or InterNACHI for deck inspections. Even if you go through the InterNACHI or NACHI certification process, you're still not licensed in the state you're in for deck inspections or engineering inspections as that goes, unless you are an engineer. Now, I am a master HVAC gas fitter, but I still don't use that in my inspections other than just an advertising, kind of thing, is that, yes, I went through the whole 9 yards, but that still does not make me an HVAC engineer. And even though in my inspection, I don't cite anything that I can pinpoint a problem with a unit and say, this is this, I always put in there, get advice or recommend a HVAC licensed contractor to evaluate and repair as needed. So like I said, you want to stay away from any kind of thing that can get you in trouble, even if you are licensed in it. I stay away from totally. And because as an inspector, you're hired as an inspector, not a technician. So that's the big difference between being an engineer, a technician, and an inspector. Just thought I'd throw in my
thank you. And that's very true. Even if you do have another license, you're not getting paid to use that license. So why take on the additional liability? Remy, go ahead.
Last
Good morning. Yes, sir. Basically, you pretty much answered my question. In that when something is hidden in the finish, like a cantilever deck, structural support and all, you just disclaim it and recommend a evaluation by a engineer, right?
Yes, by whomever is appropriate. Oftentimes it is going to be an engineer, but remember, we'll talk about this a little bit more in the reporting one, but limitation statements are so important. If you can't see it, you need to write a limitation statement saying, I can't see it. So good point. Thank you. And anybody else before we move on here? Good, good questions and comments. Hey, hearing or seeing none. Let's talk about flashing. Said it doesn't, flashing is a big contributor to deck failures. It's not only the deck itself, it's the water infiltration into the house. So we're really looking at two things here. We're talking about decks today, but remember, as a home inspector, you also want to be worrying about water infiltration, because it can contribute to that horrible, awful M word that none of us wants to get even remotely close to. Now, bolts or screws, doesn't matter how many you put into a rotted piece of wood, it ain't gonna work. And the interesting part is when you actually look at the engineering on this, it doesn't take a whole lot of rot, deterioration, however you want to say it, to have a significant impact on the strength of the wood. So it doesn't have to be to the point where you can poke your probe all the way through it. Just a little bit can cause a problem. Now, there's a pretty good example of some pretty badly rotted wood. Now, if you take a look in the reflection right over here, you see the guy taking the picture? That's me. You see the beautiful woman right over here? That's my wonderful wife. That's our house, or at least it was. We did have a home inspector. Poor guy. A few months afterward, he closed up shop in Raleigh and moved to Atlanta. I guess you at that time, I think I was standards committee chair, so maybe it's a good idea not to do an inspection for the standards chair. Anyway, there's a close up. And like I say, I don't care how many bolts or screws you put into that. Ain't gonna hold. No way. Now there's a close up of the one we saw at first, and that's why it collapsed. That ledger just pulled right away from that totally rotted out band board. And why did that band board rot out? No, improper flashing. So that's why we really want to, be careful about how we inspect and how we disclaim parts of the flashing inspection. Now, the problem you get into is that both DCA 6 and the IRC don't really tell you how to do it. They're more performance type guidelines. Basically, what they say is flash it, but they don't tell you how to do it. Could we get everybody muted, please? We are getting some crosstalk here. Thank you. Now, places to look. If you've never, the Water Management Guide, Dr. Leesbrook's book, a really good book on not only deck flashing, but all types of penetration flashing. Journal of Light Construction Field Guide, that's another good place. Or you can get one of my books, or which have a nice illustration. We're going to take a minute. We're going to go over this. This is how a deck should be flashed. You start out with, with your water resistive barrier, your house wrap. Then underneath that, you're going to want to have some kind of L flashings, because you want to make sure this vulnerable joint gets as little water into it as possible. Behind that, then you've got some type of membrane flashing. It can be any of the different types. In modern construction, it's going to be some sort of peel and stick fabric. Any of the types of flashing listed for that purpose. Even galvanized steel can work. It's not recommended these days, but it can work. Whether or not you want to leave this little gap in here, I think it's a really good idea. Dr. Leesbrook thinks it's a really good idea. You're going to get a few engineers that balk at it, and that's cool. I can understand their point of view. There is a small risk involved there, but I think the bigger risk is not having this gap in there, because it does two things. One, it lets water that will get in here, and note that I use the term will. There's no way to keep water completely out, but it gives the water a nice little drainage channel to get out. The other really nice thing is it gives the ledger itself a place to dry in both directions. Wood is a lot less likely to rot if it can dry. So then you take the membrane flashing, you lap it over the water resistive barrier, and what you've done here is created a drainage plane. Think of it like your shingles. You want everything over, all of your water resistive components, upper lapped over, lower wrapped over, lower. So any water that does get in, has a nice clean path out. So in the ideal world, that's the way a deck would be flashed. Now that kind of gives you the ledger itself, but a lot of times where a flashing breaks down is at the door onto the deck. Now, what you want to do in the perfect world, you want to have that threshold and that jamb flashing, one, present, because a lot of times it's not, and then properly integrated with the water resistive barrier. We'll have an illustration of that in just a second. Now, in the real world, what you wind up getting, if you get any flashing at all at the door, it's not tucked up under the threshold like it should be, and the jamb flashing is totally left out. So one thing you can look for is excessive caulking at the corners of the threshold. That may be there because you've got an issue. They've had issues with leaks in the past. So there's an illustration of proper pan flashing. Actually, that's what you should see on windows, doors, most of those types of wall penetrations. You want to run that pan flashing up the jamb about 6 inches or so on both sides. Then you want to turn that flashing down, lap it over the L flashing, which is then, lapped, above the water resistive membrane and the water resistive barrier. So any water that does get, in here is given a nice drainage plane out. We'll always think drainage plane when you're looking at wall penetration flashing. So here we go. We've got some nice flashing. There's your door threshold. There's a nice gap right in there. Now, do you think water's going to get in here? Darn right it's going to get in here. And that's what it looked like underneath. Take a look at that bolt and the washer. Red rust. That's telling you that the fastener is deteriorating. Look at the nail here. See the black? If you can see it, his nail's pretty badly rusted. The black around there tells you that there's wood deterioration. So what you can't see here, if this is rusting that badly, the question has to be, what is the condition of the wood behind here that you can't see? Take a really close look at this one. That's the balcony that we saw earlier. There's your roof line. See right in there, OSB. No flashing at all. That was a 1-year warranty inspection, by the way. You think that's going to leak? And what's going to happen then, over time, this winds up leaking, and this balcony, since there's your support, there's a reasonable chance that over time, this balcony comes down. Now, in all fairness, this was, I think, about a 30-year-old house. Obviously, this truss is totally gone. It's going to cost those poor sellers a fair amount of money to fix all this stuff up. Not to mention the fact that they're going to have to, spend some money on the deck itself. So flashing is not only about the deck ledger attachment. It's about the rest of the house and the damage that lack of proper flashing can cause. So we want to be, it's multiple areas, and we want to be very cognizant, of this flashing. So, okay, I hope I've gotten you to the point where you're going to be really obsessive about deck flashing. Now, what materials do we want to see? Well, galvanized steel, that is still allowed, but the problem is that it can deteriorate and does deteriorate over time, particularly with the new water, decay, I'm sorry, the preservative treatments, because a lot of your preservative treatments have copper in them now. And we all know you put copper and steel together, you've got dissimilar metals, galvanic corrosion, not a good thing. So you really, although it is still allowed, it's really not best practice anymore. The flexible flashings, say your peel and stick membranes, your fabric type plastic fabric type, if they're installed per the manufacturer's instructions, hey, it works. Aluminum flashing, no way. Not allowed anymore because it will deteriorate very badly over time. And there's, just a couple of examples of what happens to aluminum flashing. Particularly with the new copper-based preservatives. Did we have somebody with a hand up?
We do. Edward, you want to unmute and ask a question or a comment? While he's getting ready to do that, we do have a question from Daniel Fink. He asked, is flashing required if the deck is under a roof, I guess like on a porch?
Yes, flashing is required for all decks. Of course, your risk is less if it's covered by a porch, but that doesn't negate the flashing requirement at all. Edward?
All right, Edward, you want to go ahead?
Yeah. So I'm sure we've all seen it. I just want to know what the stance is on it. When we see a deck that maybe has been added to a home and they did not remove the siding where they were attaching the ledger board, they put, they did their bolts and all that. They just put a little spacer block and they just put the ledger right up against the siding.
No.
No.
Yep, it's wrong, and we'll get into that in much more detail next when we talk about ledger attachment. So good segue into the next section. Thank you.
Maybe
Scott?
we have one more, Scott. Yeah.
So what I find occasionally is on new construction, or relatively, something less than 3 to 5 years, let's say, and the contractor did improperly installed the flashing. We certainly report it, but how is it that a contractor who's supposedly Class A, Class B contractor who's building these homes can improperly install flashing? That it's just mind-boggling.
Well, the answer to that question is the contractor's not installing it. It's his subs. Now, the problem is the contractor, one, probably doesn't know, and two, isn't paying that close attention. I mean, actually, that's an excellent segue into a couple of pictures that will come up right this second. Now, and they ask us, why do you need a pre-drywall inspection or a final inspection on a new home? Because you might also ask the question, why doesn't the code inspector get it? And that's a fair question too.
Amen.
Any other questions? Good questions. Thank you. All right, let's mosey on along here. Cantilevered balcony. Run like the wind. Basically, I just disclaimed the whole thing. No flashing, at least none visible. You can see there has been leaking. That's what it looked like underneath. So when you get a situation like this, that's an example of, one, it is cantilevered. It's cantilevered fair amount. I could not see, what the backspan is on that. I can't see what the condition of the joists are inside. You basically just disclaim, run like the wind, recommend evaluation, and we'll talk more about the limitation statements in the reporting section coming up next. Another example of cantilever, this one's a little bit better. It's got some fairly decent flashing on there, but I still can't see inside. I still can't see what the backspan is. This was finished on the inside. Again, all you can do is disclaim this, write a good limitation statement, recommend evaluation, and run like the wind. Now, if you've got a situation where the cantilevered balcony is covered underneath, this is kind of a minimum here, and it's a really good illustration. You probably can't see it terribly well, particularly if you're looking on a small screen. The key thing I want you to note here is openings underneath for airflow. Remember again, rot occurs more quickly when the lumber can't dry. So you want to leave airflow anytime that you have a deck, a balcony, whatever, that's covered up underneath for any reason. If you don't see that, I call it out as a defect and recommend contractor evaluation for how to get some ventilation openings in there. Ideally, this would be large enough and have a removable grill or something that you could get up and take a look in there to see what the condition of the wood is. Just a thought. So I've kind of beaten flashing up here. We'll stop for questions or comments before we mosey on along. Anything?
Scott Harvey, go ahead.
I forgot to lower my hand. I'm good.
Okay.
Anything else, Alex?
I think we're ready to move on.
Okay. We're going to talk about ledger attachment. If it's going to have a spectacular failure, the deck is going to usually pull away for some reason, move horizontally, and then our good friend gravity will take over and pull her down. That's a good example. And interestingly note, rails, posts, they all held up, the stairs, they all held up pretty well. It was that failure at the ledger where it came down. So we want to pay a lot of attention to how that deck is attached to the house, because most of them are. Lateral loads then pull away, gravity loads then pull it down. The ledger attachment must resist both of those loads, and that's the key. Now, here's what I want you to remember. Bolts and screws are mostly for the gravity loads. Yeah, they do provide some lateral load resistance, but you have no idea how much. It's going to depend on a number of factors. Lateral load connectors are for the lateral loads. Very rarely do you see these in the wild. The lack of these is a pre-click in my report. I just have it automatically show up, and in the extremely rare case where I have actually, in fact, I can't think of a case where I've seen one. So it always is in my report. Lack of lateral load connectors. The problem you get into, even in 2021, the wording is not terribly clear about how, about that both types. Yeah, it is reasonably clearly stated, but then it goes on to reference a couple of illustrations of one way of installing lateral load connectors. We'll get into that more in a moment. The uplift may also be necessary, especially if we have those cantilevered joists. Now, there's the language in 2021. It's R5078, where supported by attachment to an exterior wall, decks shall be positively anchored, yada, 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 for both vertical and lateral loads. And I added the emphasis. So this is in the code. It has been in the code since the IRC began. So this is not exactly a new requirement. And this is the code section that's a little confusing. This is the lateral load section. Where lateral load connection is provided in accordance with these figures, well, some people, and I'll admit I was one of them until I was set straight, interpreted that as meaning that lateral load connectors are optional. All this is saying is, if you do it according to these figures, you're good. There are other ways of providing lateral load connections, but this is the prescriptive way. But that doesn't mean, or it doesn't negate this important phrase right here: designed for both vertical and lateral loads. So keep that in mind. So for your vertical loads, this is how it should be done. You want either your bolts or screws, you want to be looking at how close these are to the edge. We want at least, if we're looking at the ledger itself from the outside, we want at least 2 inches to the top. We want at least 3/4 of an inch to the bottom. Why? These are mostly for vertical load. So you don't, if this ledger is going to want to try to come down, you want at least a couple of inches of wood there to hold it. Now, if you're looking at it from the inside on the band board or rim joist, You want at least 2 inches to the top, at least 2 inches to the bottom. Now I haven't put the flashing in there for clarity. One thing I want you to note, this spacing assumes 1/2 inch screws and bolts. If you want to use bigger bolts, God bless you, go for it. But this spacing changes. It increases if you're using bigger bolts. That's what you want to see on the outside. If you're just looking at it, looking at the ledger, you want to see at least 2 inches to the edge. You want to see these bolts staggered. Why? Well, if you line them all up like that, you're liable to split the wood. So let's take a few examples. Look at this. That is an I-joist. Those are deck ledger bolts connected to an I-joist web. How thick is that I-joist web? Maybe 3/8 of an inch. This was passed by the local building inspector, but it is so wrong. Just think about, how much lateral load resistance do we have in this situation? Pretty much 0. Vertical load resistance, you're gonna split right through this little piece of OSB. This is a job for obvious man. It should never have gotten as far as it did. I love obvious man. He has so many applications.
Bruce, Ron's had his hand up for a little while, and before we get too far away from maybe your question, Ron, you want to go ahead and just pose that?
Fire away.
Well, if you go back 2 slides, the question that I'm having is, I'm not sure about in your area. Are you all required to have a building permit and then a engineered drawing? Because down here at the where you go get your building permits, they actually have engineered drawings of what you need to do for all different size decks. And I just wondered if you all have that in your area.
We are required to get a building permit. Our Appendix M to the North Carolina Residential Building Code is nowhere near as comprehensive as you describe. So basically yes to the permit, no to really good prescriptive details.
Well, ours comes with like it's a little more comprehensive what they want to see, and it gives like height off the ground, how big the post should be. It tells about backs on the stairs. It talks about the attachment of stairs to the deck. It talks about the attachment of the ledger board and the whole 9 yards. And it's like a little small pack you get when you go. And I don't know.
Well, it sounds like they've taken DCA 6 and just kind of incorporated it into their local code, because what you're describing is basically DCA 6.
Okay.
And Fairfax County in Virginia is one of the leaders in this. And there are probably others. You say here, we've got Appendix M, which, like I say, I just don't want to get, I have to not get too snarky
Well,
about it.
I think
my
we ought to go
question-
ahead and move on a little bit so we stay with, get as much material covered.
Okay, the
That's
only
right.
other thing, the only other question I have is, most of the time, or I'd say probably it's 50-50, when decks are installed, probably 50% of the time, people do not get building permits. And
Yeah.
you can see those when you go out to inspect a deck. You can pretty much see the ones that have had them inspected or have a building permit or have had a building permit, and the ones that do not.
Well, that's a good point. And here's a really good thing you can put in your report. Recommend a permit check. It's one of the most powerful recommendations you can put in a report, and it's not only for decks. It's for pretty much anything that you see that looks like some kind of retrofit where a permit is usually required, but you've got a reasonable suspicion that it hasn't been. As part of your recommendation, recommend a permit check.
Okay, thank you.
You're welcome.
Didn't mean to get off into the woods.
You're good.
Well,
That's actually good. I do, Bruce, I'm going to let you go on, but my own question is, I'm seeing a lot more of these new types of fasteners.
I'll get to those in just a second.
Great.
Excellent. Okay. Excellent question. And yes, indeed. So let's give Obvious Man his due. Let's connect it to OSB sheathing. And yeah, that little block of wood, I'm sure really helps a lot. That was a pre-drywall inspection. The builder actually fought me on it. The recommendation was to get an engineer. The engineer came out, laughed, and moved on. Another job for Obvious Man. Think that's going to work really well? I don't think so. Problem here? Yeah, got some really nice bolts, but do we have 2 inches there? No. Also, installed through brick veneer. That's actually allowed here in North Carolina, and that's one reason I get so snarky about Appendix M. But we'll move on from that. Oh, we got so many good ones here. Carriage bolts? No. How big should that hole be? It should be just big enough to get the bolt through. We unfortunately won't have time to talk about the issues with this joist hanger. And of course, in your area, it's not allowed to install through brick veneer. In most of the civilized world, it's not allowed. So, there's all sorts of really good errors here. You're talking about the recommendation for requesting a building permit check. This would be a good one for it. Yeah, let's attach it to brick veneer with Tapcons. I'm sure that's going to work. Probably no permit. Fastener spacing? Probably not. Nails? Get into older decks. You're going to find some that are attached only with nails. That gets a red colored comment in my system, and a do not use this deck warning. Nailed only ledgers are extremely dangerous. There's zero lateral load resistance. There's minimal vertical load resistance. Yeah, it may have been here for a long time, probably has been for a long time. But the longer the time, the more likely it is that there's deterioration where you can't see. And you don't want to be the inspector who inspected the deck where it came down with your clients on it. Here's an interesting one. You see this little bitty piece of ledger right here. There's another view of it, with a double on it, no less. Do you think there's any chance that all this is bolted to the house? Basically, no, there isn't. The builder is still fighting us. This is an active engagement for me, and the builder's still fighting us on it. Be interesting to see what happens. Now, here's an interesting one. Question becomes, you've got this garage door here. Is that garage door header, do you think, sized to handle the additional load of the deck? Probably not. At a minimum, you're going to want to recommend further evaluation of something like this. Maybe, maybe not. I don't know. No way for me to tell. So let's get into Alex's question then about alternative attachment methods. These are great. They really are. You just need to be really careful about them because similar products, the designations, the models look very similar, but they're not the same. So in the Simpson line, just for example, your SDWS and SDWH timber screws are listed for joist attachment, but the SDWS framing screws aren't. The SDS heavy duty connector screws are. The SD connector screws are not. They're different. And then you've got ledger locks, other brand names. There are a lot of different alternatives to this. Did somebody have a hand up? Scott Harvey?
Yeah, on the previous slide, Bruce. Yes, previous slide, please. So I do see this flashing technique a lot. And this is not what we discussed. But there may be additional flashing not visible in the slide.
Yep, and that's there's several issues here. I just wanted to concentrate on this. The flashing, probably wrong. It's through brick veneer, which is also wrong. One of my standard limitation statements every single deck inspection is that I can't see all the flashing details. So I want to make really sure that people understand that limitation. Does that answer your question, Scott?
Yes, thank you.
It's just a good general limitation. Mark, yeah, go ahead. Mark Ludner, just unmute yourself. Well, I'm going to move along here.
Okay. considering the time that's left and everything, I'd ask if you'd like to comment on the fact that most of these inspectors have been taught you do not install a deck ledger on brick veneer. Could you talk about the fact that now there are specific means and fasteners that are generated to allow that? Okay, because people are still writing up, you can't do it because they don't understand how you can do it.
Yes, Simpson does have a product that allows for this. It's not cheap, but you can do it. And if you happen to see that specific connector, then basically, I have not actually seen it in the wild yet. It's pretty new. But what I would do if I see it is disclaim and have somebody look at it for installation according to manufacturer's instructions, because that is critical. Ledger locks, these are just pictures of them. Pictures of the different types of alternate fasteners that you might see and are allowed if your local jurisdiction allows them and if they are installed per manufacturer's instructions. And that's what, there's kind of a fuzzy picture of one. That's picture of another. Is that installed per manufacturer's instructions? No. And that's really the key. This is an easy one. It is definitely not installed per manufacturer's instructions. Now, are we required to determine installation per manufacturer's instructions? Not on a home inspection, no. So you might want to disclaim these, at least insofar as installation per manufacturer's instructions goes, because it gets a little complicated. Here's the manufacturer's instructions for the SDWS screw, and just look at what you get here. You've got OSB and LVL rim boards. You've got different thickness rim boards, and then you've got standard dimensional lumber framing. Your spacing is then going to depend on your joist span. Is it required that we inspect for this? No, we can't. We just don't have the time. It is out of scope. But this does kind of give you an idea, of the complexity involved in selecting the fastener and then determining what the spacing is supposed to be. Now let's talk about lateral load connectors. Remember, they are some type of lateral load resistance is required. This is this is one of the prescriptive ways of doing it. In the Simpson line, this is a DTT2 connector. You basically put one of them on the house floor joist, you put one of them on one of the deck floor joists. They sell you a nice long threaded rod. You put it in between the two, and life is good, except for, note right up here. There is a floor sheathing nailing pattern that you're supposed to have on the interior house floor to make all of this work. In most cases, in a home inspection or even in a deck inspection, are you going to be able to see this? Probably not. So you're going to want to disclaim at least that part of it. There's what they look like in the wild. Basic DTT2. See, these have a lot of different uses. This is one of them. In this particular case, we're looking at I-joists. So you need to, it's a different way of doing it with I-joists. In fact, this is a different way, even if this was dimensional lumber and they were parallel with the band. There's the band joist over here. This is one way of doing it. There's one of the alternatives. This is the Simpson DTT1 or the equivalent from another manufacturer. You put one over here, then you basically screw it into the plate or a wall that bears on the foundation. You put 4 of these in, you put 2 of the other ones, but note here, the house floor joists must be parallel with the deck floor joists or perpendicular to the house band joist if you prefer, and that's required for this. So there's a close-up of what they look like. There's your DTT1, 4 of those. They're about $40 or so for a pack of 4 with all the hardware. There's your DTT2. You need 2 of these, 4 of these. A lot of different ways of doing it. This is from Simpson manufacturer's instructions. So if things don't line up, well, you can put it on the bottom if it lines up there. You can screw it to the side if it lines up better there. Okay, so that's lateral load connectors. Let's talk about connecting to wood trusses. Basically, gravity loads, you're just going to use bolts and screws. There is an industry standard diagram for doing that. You can get it at sbcindustry.com. That's a good source for that, but you're still going to need your lateral load connectors, DTT1s, DTT2s, however it winds up doing. That's the SBC diagram. It's pretty much the same as everything else as the other ones. You'll note that it comes in that you want to see a double web there, but otherwise your spacing is pretty much the same. So there's one. It would have, if this had had 2 in them, it would have been right. So, just put another one in. If they had only put them through the trusses, things would have been good. But they did it this way. They just put some blocks of wood. Vertical load, maybe. Lateral load, no, virtually none. And we'll just kind of ignore the fact that the wood is split on this one. This one is too close to the edge of the wood to do a whole lot of good. Builder never did change this. The local code authority passed it. Shouldn't have, but they did. So let's talk about then, why are you not supposed to connect decks to cantilevered structures? Well, there's a good illustration of why not. What is holding this board on? Well, it's basically nails loaded in withdrawal. The National Design Specification is very clear about this. Nails loaded in withdrawal are not permitted. So, and this kind of shows you why. this is moving. It's separating out. Bad juju here. Another example, do you think what is this ledger connected to? Well, inside here, it's a band board that's probably nailed in. So essentially you've got loading of nails in withdrawal. Not to mention the fact that this cantilever itself is probably not designed for the vertical load imposed by that deck. It's probably just barely designed for the roof load and the wall load, or the floor load for the house itself. This is wrong on multiple levels. Kind of hard to see. This is the other side of that balcony that we saw earlier. If you look really closely here, that's a soffit. So this deck is supported most likely by either something in the soffit itself or just by the fascia. 1-year warranty inspection passed by the local building official. So let me get into deck stairs really quick while we've got a few minutes. They're one of the most dangerous parts of stairs, and that's why. In this particular case, you had a drop header, nailed only, just no good. So there in one illustration is is how it ought to be done. If you're going to do a drop header, it should at least be bolted. Ideally, you want at least 5 inches between the cut stringer and the edge of the stringer itself. Those stringers by DCA 6 should be 2x12s. Ideally, you want a good landing at the end. If your stringer spans 6 feet for Southern Pine cut stringers, 13.3 for solids, or for solid stringers. And if you do overspan, you can support them with 4x4 support posts, on footings. Now the stringer attachment to the rim joist, that's usually your weak connection. Almost always attached using nails, and they can work. It's better to have stringer connectors, but I have yet to see too many of these in the wild. This is the Simpson Lsc connector. This is the connector that is actually listed for stringers. Ideally, that's what you'd want, and they're not that expensive. So I don't know why, more of your deck builders don't use them. Now, there are other possibilities, using angled joist hangers, and if you install them per manufacturer's instructions, they should work. Now, here's an example of a good try. It's not seated properly. You don't have fasteners in all the holes. You're using deck screws. You always install joist hangers per manufacturer's instructions, and those instructions do not include deck screws. Now, nailed stringers, the problem is these stringers can be subject to withdrawal. And remember, we said nails loaded in withdrawal are no good. Small plumb cuts, you want that entire plumb cut, the vertical cut of the stringer, you want it large enough and you want it completely supported. So here's an example. You know, there's your drop header right there, a nailed drop header. Nailed drop headers are always wrong. You always report those. Now, this doesn't look too bad, but this is a nailed drop header and nails loaded in withdrawal, because you have, this board, is nailed up to the rim board. Then this board is nailed there. This board is nailed there. All of those are subject to, vertical loads. So they are all loaded in withdrawal. Really? That's an uplift connector. Pretty unlikely that that is listed for this application. You want to compound the felony? That's a that's a guard post. So you're not only are you loading this improperly, you're also potentially putting a twisting load on this connector with a guard post. Just one of the many things you want to watch for. Got 3 lonely little nails up there. That really, let obvious man out here one more time. That, that's wrong on so many levels for this reason. Would you want to walk on that set of stringers? Sometimes the nails stay in and the stringer moves. That stringer, if you're going to use nails, those stringers have to be secured against horizontal movement. Otherwise nailed stringers are wrong. And say thank you.
Very good. Thank you.
If you have any do we want to take a moment for questions?
Yeah, why don't we do that?
Not sure about the other one. Yeah, where can I get it?
My books are available on my website, dreamhomeconsultants.com.